Welcome students. Today we are going to start new chapter that is whole numbers. Topics to be covered in this chapter are introduction, natural numbers, whole numbers, successor and predecessor of a number, operations on number line like addition, subtraction and multiplication. Then we'll discuss properties of whole numbers like closure property, commutative property, associative property, and distributive property. Then we'll discuss number patterns. Whole numbers. So, whole numbers is basically a category of numbers, and whenever we talk about numbers, they play a very critical role in mathematics because mathematics is the science of quantity. That is what was told by great philosopher Aristotle. So, whenever in mathematics you deal with anything, you basically deal with quantity. You basically deal with how much of a particular thing is. For example, you go to a market to buy tomatoes, and it becomes very important to define to the shopkeeper that how much tomatoes do you need. And when the shopkeeper asks you that how much tomatoes you need, so what do you say? You have to say a number. You will say that I need 10 kgs of tomatoes, or 10 pieces of tomatoes. So what is 10? 10 is nothing but a number. When you really score well in exams, doesn't matter how you score, but your score again come is again a quantity. Sometimes you score 95% or sometimes you score 92% or sometimes you score 70%. So you might say like it how it is in grades. So in grades they are uh, they are also given on basis of numbers because again your exam is again a process to evaluate the numbers, evaluate the performance based on the quantity of marks you scored, right? Which is given in terms of numbers. You buy anything, you have anything like pen, pencil, chocolates, or toffees. Now, how do you ensure that how many toffees you have? So right now on the screen you have five candies here, right? So five again is a number which defines the quantity, right? Quantity of chocolate or toffees. Now there are many different types of numbers that exist in mathematics. So to start with, we'll first talk about the most common numbers. Yes, they are natural numbers. So what are natural numbers? Okay, forget about natural numbers. Think of a scenario that you have a 3-year-old kid, maybe a kid who just have started, um, who had just started going to his or her preschool, and he has just started learning ABCD. And when you ask that kid to start numbering, to start counting, how does he count or she count? The king will start counting something like this, like one, two, three, four, five, six, and so on, right? So, what are these? One, two, three, four, five, six, seven. These are nothing but numbers, right? And these numbers are the ones which come most naturally to us, and it comes to us very easily. When you are given a bunch of, say, mm, bunch of bananas, and if I ask you to count the number of bananas, how are you going to count? You are definitely going to count it in this way: one, two, three, four, right? So you are starting with one, followed by two, three, four, and so on. However, that doesn't mean that only one, two, three are our numbers. We also have like 1 by 2, half, 3 by fourth, something like 0.25. These are also numbers, right? But these are little complicated numbers, right? So, have you ever counted anything like 1 by 2, 3 by 4, 4 by 5, 5 by 4? Have you counted ever like this? No, we generally count like 1, 2, 3, 4 because that comes naturally to us. So, these numbers which come that has come very naturally to us are called natural numbers. So, when you look at your hand, so how many fingers do you have in your hand? In fact, in each hand. So, there are five fingers. So, what is five? Five is a natural number. So, do you think that you can count the number of hairs on your head? Tough, right? But it's not uncountable, right? You can count, but it's going to take huge amount of time, right? Large amount of time. So basically, when we talk about natural numbers, I hope you have by now you have understood that where do natural numbers start? Where do from natural numbers start? So natural numbers start from 1, 2. That is where we start counting starts. But the question is where do the num where do the counting continues? So just to explain that, I gave this example of counting your hair. So when I ask you to count your hair, there are so many hairs on your head that it's really a difficult task to count them because you feel as if they never end. They You never finished counting. So we know that the number starts from one, but when you look at the end point, it's actually endless. So they continue till infinity. So there are infinite numbers of natural numbers. So the initial numbers, like 1, 2, 3, 4, you will reach 10, thousands, lakhs, 10 crores. You will keep reaching on 7 digits, 8 digits, 9 digits numbers, and the list will never end. So all the numbers starting from 1 till infinity, they are all natural numbers. Now, I said that counting starts from 1. So the moment someone asks us to count, we start from 1. But is there anything that exists as below 1? Like if I ask you what exists before 3, you will say 2. If I ask you what exists before 2, yeah, below 2, you will say 1. What exists before 1? Is there anything that exists before 1? So let's have a look at this. So uh, say this little boy has five candies it with him. So if I remove one, how many are left? Four, right? If I remove one again, what's left? Three. Remove one, then two. Remove one, then one. So one is left. But what will happen if I remove this one candy also? Say I removed it. What do you think? How many candies this boy now has? How many candies are there with him now? Zero, right? So zero exists below one. So just before one, we have something that's zero. Zero is nothing, and when there is nothing present, we say it's zero. The number is zero. Okay? So zero is a number which basically defines nothing. Now let's introduce the concept of whole numbers. And a whole, so see, zero is now an very important number. So if you don't have zeros, you don't have 10. you won't have 100, you won't have 1000, 40, 50, 60. So everywhere you have zero, and zero is um, so zero is very significant there. So whole numbers are those numbers which include zero plus all the natural numbers. So basically, to include zero, this new name was given to the type of number, and this name was whole numbers. So whole numbers means complete. So the complete set of all the numbers, which includes all natural numbers plus zero. So that is whole number. Now, if you look at, there are a lot of places where the counting starts from zero. For example, if you have ever observed the timer or the digital clock, they first starts with 00, then 01, 02, 03, and so on. So zero is very crucial. Now, the moment you add a zero after a number, for example, you have a bundle of say 300 rupees. This is how we write 300, right? Now, let's say if I keep increasing the number of zeros, what happens? The amount of money which I'm talking also increases. So it's not that zero is insignificant, but the moment you keep adding zeros to a particular digit, the value of overall number increases. So presence or absence of a zero makes a huge difference, right? Now, when I say that there's one student in the class, and when you say there are 10 students in the class, do you think they mean the same? No, there's a lot of difference between the two, right? But when you actually see, you write 1 for one student and you write 10 like this. So this is due to the presence of 0, that the entire number changes, right? So the 0 is very crucial. So that is why the concept of whole numbers came into picture. Now, in this lesson, we are going to talk more about whole numbers. We are going to talk about the properties of whole numbers. We will see how to add, how will we subtract the whole numbers. We will learn all the basic things with regard to whole numbers.